Welcome back to another exciting episode of Geometry with Mr. Marchetti. We're going to be talking about arcs and angle measures today. Well, there are two different angles that we can make inside of a circle that are really specific. One that we're going to talk about is a central angle. That's the first one we're going to talk about. Now, a central angle, as you can see by the definition, tells us it's an angle that's formed with the vertex located at the center of the circle. So if you notice the center right here, B, I have an angle ABC. Its vertex B is located right here at the center. That's why they're called central angles. Then we have this little star piece of information here. There's actually a theorem. The theorem tells us that the measure of a central angle is equal to the intercepted arc. So you notice our angle is hitting the circle and it's creating an arc right here highlighted in yellow or orange, I'm sorry. Okay, so what you notice here, what the theorem is telling us is that the measure of angle ABC, whatever this happens to be right here, is going to be equal to the measure of the arc AC that's being intercepted. Okay, so it's pretty easy. You're going to see the problems. It's basically just make two things equal for these few problems. Okay, so there's a lot of problems that are going to be given for this section. So if at any time you want to try them on your own, just pause the video. I'll give a good couple of seconds pause. You can pause it, try it out, and then resume the video when you're ready to check. Okay, because there's a lot of these to do, so please feel free to do them at your pace. So the first problem that they give us the central angle located at A at 71 degrees. And we know that angle is equal to arc. So if angle is 71 degrees, that means that the arc must also be 71 degrees. Okay, so arc BC is 71. Okay, it's just that easy. Problem B. Here, the angle is what we're looking for. And we know angle is equal to arc. The arc that they give us right here is 153 degrees. So that's what the measure happens to be. Okay, so a measure of angle LMN is 153 degrees. Okay, two more problems to try out. Here again, we're looking for the angle. We know that it's going to be equal to the arc. The arc is 90. That makes this angle also 90. So angle PQR measures 90 degrees. And our last problem. Here we're trying to find the arc. This is a central angle. That makes the measure of the arc equal to that angle, which is 138 degrees. The arc in question here is arc XZ. So the measure of arc XZ is 138 degrees. Okay, pretty easy, pretty basic first few problems. Hopefully if you tried those on your own, you did well with them. The next couple of problems, they're really not going to be much more difficult. They're just going to be a little bit more involved with numbers, right? Before it was just simply an angle measure and then we said that they're equal. Here you see now we're trying to solve for x, and they give us little equations for each, right? We're going to have to work with those. Now it shouldn't be a problem because remember, angle is equal to the arc. So I'm going to take the angle measure that they give us, set it equal to the arc measure that they give us, and then solve. So here I have 4x minus 13. I'm going to set that equal to negative 2x plus 11. I'm going to add 2x to both sides. I'm also going to add 13 to both sides. That's going to give me 6x equals 24, and then I divide by 6. X equals 4. Okay, so there's one more of these types of problems. Again, if you would like to try it, here's what we're going to do. We're going to take the angle measure, 7x plus 23. We're going to make it equal to the arc measure, 2x plus 33. Okay, I'm going to subtract 2x from both sides. I'm also going to subtract 23 from both sides. That gives me 5x on one side equals 33 minus 23 is 10. We'll divide by 5. That gives me a value of x equals 2. Okay, hopefully these problems were pretty easy. Central angles tend to be pretty easy. The next one that we're going to look at, which you can already see on the screen, is an inscribed. Okay, an inscribed angle is an angle whose vector is located on the circle and whose arms are chords of the circle. So notice, here you can see the angle we have, angle ABC. The vertex is on the circle itself. It's no longer in the center. It's on the actual circle. And the arms of that angle, AB and CB, they're chords. Their endpoints both lay on the circle. Okay, so this is an inscribed angle. One of the theorems that we're going to notice about inscribed angles is that the measure of the inscribed angle is equal to half of its intercepted arc. Okay, so here we see that we have measure of angle ABC. It's going to be congruent to not measure of AC, but we said half. So we want to make sure that we involve half in our formula. Okay, I'm going to make that even darker just so you can see it more clearly. Okay, we're talking about half of the measure of angle AC. Now, real quick before we start problems, I still write this before I work on inscribed angle problems. Angle equals 1/2 arc. And then I plug in the values that they give me for either the angle or the arc, and it's going to make my life a lot easier because I know which one the half is supposed to be attached to. It's supposed to be attached to the arc. And it's going to make either my multiplication or division real simple to do, but I'm going to make sure that I do it to the right side. And you're going to see in these problems exactly what I'm talking about. And again, if you'd like to jump ahead and try these on your own pace, that's fine. Go at your own speed. Okay. Problem number A. Okay, they ask us to for each of the following solve for the indicated arc or inscribed angle. So here they give us the inscribed angle. We're trying to find the arc. Well, again, angle equals 1/2 arc. My angle that they gave me is 36. I'm trying to find the arc, so I'm just going to call that x. There's only one step for us to do here. If I'm dividing by 2, if I multiply by 2 on both sides, I'll get rid of that 1/2, and I'll just have to double this side. 36 times 2 is 72. So the arc that we're talking about here is 72 degrees. Okay, and notice, this is half the size of this arc. That's what we're hoping for. Okay, new problem. Here's the angle we're looking for. Here's the arc they gave us. Again, angle equals 1/2 arc. I'm looking for the angle, so that's going to be my x. I know it's going to be 1/2 times my arc of 112. Now look, right here, we don't have to do any multiplication to get rid of anything. We do our multiplication because it's exactly what they tell us to do. Right? They ask us, what is half of 112? So, easy enough to do on your either long division calculator or in your head. 112 divided by 2, that's going to give us 56 degrees. Okay? Let's check out a couple more problems. Okay, again, they're giving us an arc. I know my angle is equal to 1/2 of that arc. So x is what I'm trying to find. Arc they gave us is 174. So 174 divided by 2 will give us our solution. And that happens to be 87 degrees. And our last problem, they give us an angle. We were looking for the missing arc. Remember, angle equals 1/2 arc. Angle was given to us as 61. We're trying to find arc, so we'll call that x. We would need to multiply by 2 on both sides to clear out that half. So 61 times 2 is 122 degrees. That makes this arc right here 122, which is definitely twice the angle of 61. Alright. These next two problems, they're really not that bad, again, as long as you set up the proper formula. Okay? Solving for x is not that big a deal as long as you set it up right. Our angle is equal to half the arc. The angle they gave us is 6x minus 2. That's going to be 1/2 of 11x plus 3. And if we remember to just repeat the same kind of process, we'll be fine. I need to multiply this by 2 to get rid of the half, which means I need to multiply the other side by 2. Just be careful. When you do that, you need to make sure that you distribute all the way through. So that gives us, I'm going to write it over here, 12x minus 4, that's this side, and we got 11x plus 3 left over. And let's just solve for x. Subtract 11x from both sides, add 4 to both sides, 12x minus 11x is 1x, 3 plus 4 is 7. That's my final solution. Okay, so one last problem that you can try out on your own. Let's check it out. So angle equals 1/2 arc. The angle they gave us here, 5x plus 7, has to be equal to 1/2 of 14x minus 10. I'm going to multiply by 2 on both sides again to clear out that 1/2. Let's make sure that we distribute to both terms. So that gives me 10x plus 14. We have 14x minus 10 left on the other side. And then we're going to solve. Subtract 10x, add 10. That gets rid of my 10x from here. That gets rid of my 10 from here. Let's see. 24 equals 4x. Divide by 4. X equals 6. Again, hopefully you did alright with that. Alright, your homework is going to have a few problems that look similar to these. Now, don't let these bother you, okay? Because what you should notice here is that we have an inscribed angle and a central angle that are intercepting the same arc. Well, that's a good thing, because if we know the central angle, we automatically know the arc, and we know that the inscribed angle is half of whatever the arc is. So basically, if they give us the central angle, just need to take half of it and we'll figure out the inscribed angle. Okay? So let's check it out. This problem tells us that we have a central angle of 110, which makes our arc 110. And the inscribed angle is half of the arc, so half of 110 is 55. So here we have x equaling 55 degrees. Okay, again, remember, these are equal. This is half. Problem B. Well, 43 is half of this arc. So we need to double 43 to get this arc measure. So 43 times 2 gives me an arc of 86 degrees. And now that I know that arc, I know that this angle has to be equal to it. That gives me x equals 86 degrees. Okay, they're that easy. Two more to try. Here they give us the inscribed angle. We know it has to be half of this arc. So 62 is half of what number? In other words, if we double 62, we're going to get what? All right, that's going to give us 124. And remember now, our central angle is equal to our arc. That means that x equals 124 degrees. And last problem. Central angle is going to be equal to our arc, so they gave us a central angle of 98 degrees. Our inscribed angle is going to be half that measure, so half of 98. That's 49 degrees. All right. We have one more little bit of information to go over with central and inscribed angles, specifically inscribed angles. Here's our final theorem. This final theorem on inscribed angles says if two inscribed angles intercept the same arc, then the angles are congruent. So here you notice we have one inscribed angle, angle 1, highlighted in green, intercepting arc AB. Our second angle, angle 2, in orange, is intercepting the same arc AB. Seeing as they're both intercepting the same arc, they must be congruent. It makes sense too, right? Inscribed angle is half of an arc. This inscribed angle is half of the same arc, so they're both half of the same number. They would have to be the same amount. Okay, makes a lot of sense to me. So here are the types of problems that you're going to see with this. Okay, they ask us to solve for x, and they give us the measure of some angles. They give us measure of angle ABD. Here's ABD. It's intercepting this arc right here. I'll highlight it in red. That's AD. And then they give us measure of angle ACD. ACD is intercepting this arc rather in purple, and you notice that it's the same arc. Because it's the same arc, they must be equal to each other. So we just take the two measures. 16x minus 41 has to be equal to 9x plus 1, because these two inscribed angles must be equal, seeing as they intercept the same arc. Let's just solve. Subtract 9x, add 41. That gives me 7x equals 42. Divide by 7. That gives me x equals 6. Okay, so again, these problems shouldn't be difficult as far as the algebra goes. It's all a memorization. If you can remember that inscribed angles intercepting the same arc are congruent, then you just set them up equal to each other. Okay, so here's the final problem for this video. Again, if you'd like to try it out on your own, go for it. Pause the video and resume when you're ready to check. So let's check this one out. We're trying to solve for x. The measure of angle PQS. PQS, that's intercepting this arc right here. And they give us PRS. PRS, that's intercepting the same arc. So what do we know about these two angles? They must be congruent. And seeing as they gave us values, we should just take those values and set them equal to each other. So 12x plus 184 equals 35x. I'm going to subtract 12x from both sides. That gives me 184 equals 23x. So we need to divide both sides by 23. So 184 divided by 23, that gives us 8. Alright, well, that's it for central and inscribed angles and arcs. Any questions you have, please leave on the website or bring them into class. I'd be more than happy to answer them for you. Hopefully you're starting to pick up this stuff pretty well, and I'll see you next time.